Okay, welcome everybody. Before we get started, I just want to touch on some housekeeping. Today's session will be recorded, and if you have any questions, please feel free to either raise your hand or use the chat function. If I could ask that mics are turned off while we are going through the presentations, and we also recommend that cameras are turned off. But please feel free to turn them on if you have any questions. On today's agenda, you'll hear the ICE work plan update, our Heatmap Tool and the Appendix G Process, the network Headroom report, distribution system operation update, and at the end of each presentation, there will be an option for questions, and at the end, we'll open up the panel. We're also looking to break out into smaller discussion rooms, then wrap up and close. On today's call, you'll be hearing from Victoria Brown, Gareth Freeman and Keith Evans, and John Carlisle is here to support with any questions. From the ICE team, there's myself, Lottie Wheatcroft and Hannah Sherratt, and we're also joined by members of our senior leadership team with Stefan Jones and Brian Hoyes. To get you thinking about which discussion room you might like to join, the topics we'll be covering are here. Each room will be supported and hosted by one of our ENWL experts. So Victoria covering applications, Gareth and Keith network information, John with delivery, and Stefan will be covering general. If I could ask that during the presentation in the chat, please just add which room or topic you'd like to join, and there will be an option to kind of move between rooms if you want to cover a couple of topics. I'll now hand over to Hannah.
Good afternoon, everyone. As Lottie says, welcome to our Distributed Generation HV and EHV Workshop. This presentation is just a brief update on how we're progressing on this year's ICE work plan. Okay. So for those of you who aren't familiar with our ICE work plans, each year we work with our stakeholders to agree a list of commitments to deliver within the year. And here I'll just give you a bit of an update on how we're progressing with this year's commitments. So on the first item on our commitment, our work plan is around the delivery of queue management, which is to enable slow-moving projects in line with revised industry best practice. So this is complete as of July. So we implemented the process from the 1st of July and have done a couple of presentations, one in July's session, and the recording is available on the slides. The next one is around keeping you updated on significant code review, which is a change Ofgem are looking at. We have done a presentation in July. Again, we have a recording available and have done a webinar in August. Now, our plan was to deliver a further one towards the end of this year when Ofgem publish their decision on the significant code review. That looks like it's going to be the very end of March when Ofgem publish that, so it is likely our webinar to explain what that decision means is going to drop into next year. That's something we will obviously deliver. And the next one is around flexible services, and we do a number of items there. We've done a presentation again as of July, and we've also got a flexible services event planned in November. So if you're interested in that, let me know and I can put you towards the website to register, and we'll be doing further updates in spring. We also committed to keeping you up to date on how we are transitioning ourselves from distribution network operators to distribution system operation. And we've got Keith with us today, who's going to deliver a presentation on that, as well as our strategy, which is published on the website. And then the ones on this slide are more around how we engage with our stakeholders and some metrics in terms of the performance of things we deliver to yourselves. So we've got commitments on communicating with yourselves through webinars like today, and also through newsletters and other communication channels. We also have put an SLA on our surgery sessions for the first time, and targeting that these are all held within 10 days. At the moment, we're running at an average of holding our surgery sessions for this stakeholder group within 5 working days, which is fantastic. And as you can see, we also have metrics on our time to quote for HV and EHV, which are outperforming the guaranteed standards. Now, you can see the one for EHV is showing as amber, and the reason being is currently working at 60 working days due to some resourcing constraints, but we are expecting that to be resolved and to bring that back in line before the end of the year. As with all our events, it is a two-way street. We are here to hear your feedback as well as to present information to you. So if you do have any feedback either on the event or on any of the presentations or any of the topics, please either put something in today's chat or email us at ice@enwl.co.uk. One of the ways we look to get some feedback on yourselves on these events is to do surveys on the event itself. So we will very shortly be publishing in the chat function a link to our survey. It's just gone on now. If you can, at some point during the presentation or at the end of the presentation, fill that out, that will give us some valuable feedback on what we can do at our next event. Any final questions? In which case I shall hand over to Victoria. Thank you.
Thank you, Hannah. So as Lottie mentioned at the beginning, my name's Victoria Brown. I'm the Infrastructure Solutions Programme Manager on the bid side of things. So I think I've had the pleasure of dealing with a lot of you before. And what I'm going to do today is just give a quick overview of our Heatmap tool, which I'm sure quite a few of you have come across previously. So I'm not going to look to spend too much time on that in the presentation. But if you have got any questions, feel free to ask me kind of at the end. Or at the end of today's kind of workshop when we're in the breakout sessions. So with our Heatmap tool, it's an Excel sheet that's downloadable from our website, and I have put a link to that further on, which you'll be able to utilise when we send the slides out to you today. But that's really an overview of what the Heatmap tool looks like. So it has a number of tabs that let you input information for an HV connection or an EHV connection, and then it gives you the idea of headroom on our primaries, on our BSPs, and also on the transmission network as well. So this is the slide that covers HV connections. So as you can see, it allows you to input the coordinates for your site. You can input the size export that you're looking for, or the size import if you're looking for a demand connection. And then in the connection type, you can either select demand or generation, and you can either select inverter-based generation, which we've got on the example here, or synchronous generation or battery storage if you're looking to install batteries at the site. It will then give you kind of this overview. So you'll get 10 of the nearest primary substations, and then we have a red, amber, green status towards the right-hand side. So you can see at a glance whether or not those primaries have sufficient capacity to accommodate the size connection that you're looking for. We also recently added in a limiting factor, so that's the furthest column on the right hand side. So you can see here on the example that I've highlighted, we're saying on that example, even though technically there's headroom on the primary, it's limited by the rating of the switchgear. So you wouldn't be able to install the 7.5 megawatts at that primary. You'd have to reduce it down to the 7.2 that's indicated in the column. Similarly, the 33 kV tab looks exactly the same. The only difference there, though, is that we don't give the limiting factor. So this is because as you get up the voltages, the complexity of the network does increase. So we aren't able to give that limiting factor on the 33 kV connections, but right at the top, we do sort of indicate the maximum that we could accommodate on a single circuit connection at 33 kV. Because we've had some feedback that where it's sort of indicating that there's like 100 megawatts plus of headroom on the BSP, people have been kind of applying for that and expecting to get a 33 kV connection, which isn't going to be viable. So that's why we've indicated that kind of maximum threshold there for you. Also as well on the right hand side, it indicates kind of transmission constraints. So you can see there that for all these BSPs, they're ultimately feeding the top 3 into Padiham, then into Penwitham, then into Rochdale. And then for all of those, it's indicating that a modification application is required. So for the rest of the presentation, I'm going to focus on kind of transmission capacity and our Appendix G process that we go through, which should hopefully kind of answer any queries you've got on that, and then give you the chance to kind of ask me anything else that doesn't get covered. So this is the transmission capacity that's shown in the heat map. I'm going to go over this very quickly because I will revisit this at the end once I've explained the process. So you've got a little bit more context there rather than me just explaining a lot of numbers to you that don't really mean anything. But the main thing I wanted to highlight on this is that this is an indication of transmission capacity headroom. It doesn't indicate capacity on our network at the 132 kV. So currently on the heat map, we don't have the capability to show 132 kV headroom. So the best way to kind of approach any 132 kV connection that you may want to apply for is to arrange a surgery session, as I mentioned previously. You can get in touch with either myself or one of the planners in my team, who will then be able to kind of talk you through the potential for a 132 kV connection in any area you're looking at, because that's not something that we can facilitate with the heat map at the moment. So as some final thoughts on the heat map, it is only intended to be used as like an indicator. So at the very early stages of your application, it can be very helpful to know that if the site you're looking at, all the nearest substations are red, pretty much okay, that you can move on and look at another site. But it isn't a guarantee. If the headroom says there is capability, if you do come to us for a formal offer, there's no guarantee that the point of connection given in the formal offer will reflect what you've seen in the heat map. That's because at the end of the day, it is just an Excel spreadsheet. So there are lots of different kind of permutations of the network that we can't capture in those calculations. So there can be issues with things like voltage step or voltage swing, particularly for batteries, that we'll only kind of see out of doing network modelling, which we do when we get formal applications. So as I say, a handy tool to have, but not kind of, it won't give you kind of a guaranteed point of connection moving forward. If the tool as well doesn't indicate capacity in the area you're looking at, or there's any kind of elements that you're not particularly sure on, you can arrange, as I said, the connections team surgery session. So that will either be with someone in my team, or if it's less than a megawatt, it will be someone in business connections, and we'll just be able to discuss your kind of requirements with you and then the best next steps for you to take. So again, all the information in the heat map's kind of correct when we publish it. So we do update the heat map on a monthly basis, and the background information, it will reflect any acceptances that we've had in that month, but also any cancellations that we've had as well. And then we also update the new switchgear information quarterly. The reason for doing that quarterly is just purely because we don't go around changing switchgear very frequently. So we deem that it's kind of frequent enough to do that on a quarterly basis. So before I move on in more detail to the Appendix G process, were there any questions anyone had on the heat map? Nope, silence is golden, okay. Right, so this then is an overview of the Appendix G process. So the Appendix G process, it's the mechanism that we as the DNO inform National Grid of changes to contracted capacity on our network. So those changes will represent any acceptances that we may have had, but also any cancellations that we've had as well. So it's applicable to any generation connection that's 1 megawatt or larger. So if you come to us and accept any scheme, any generation scheme that's a megawatt or larger, it will need to go into this Appendix G process with National Grid. So each GSP, which stands for Grid Supply Point, they're given a thermal headroom and a fault level headroom that's calculated by National Grid as part of this process. All this information kind of comes to us as a lot of numbers. So what we've done is we've given each GSP a materiality status. So the reason why we've done that is to try and make it much more kind of meaningful for people, again, to be able to sort of see at a glance whether or not there's going to be any problems with the feeding GSP for their connection on National Grid's network. So if you're looking at the heat map and you see that it has an A status on the GSP, that means that the newest information we've had from Grid shows there's spare transmission capacity in that location. However, if it's got a B status, it means that there's insufficient capacity without us undertaking a further assessment. So that assessment can have one of two outcomes. It can either lead to reinforcement on the transmission network, or it can actually lead to National Grid saying that the connection can go ahead without any further works, but I'll cover that off again in a few slides. And finally, we've got C status. So C status is probably the most depressing if you're looking at a site and the GSP has a C status. So that means that we can't allow any further connections to energise that are fed by that GSP without undertaking work on the transmission system, but we do already know kind of what that work consists of, what it will look like, and can give a rough indication of timescales and also of price. Okay, so I've kind of broken the process into two. So the process where we have sufficient headroom, and then the process where we have insufficient headroom. So in this example here, we're going to have sufficient headroom. So a generator's applied to us for a connection and they've received their connection offer. We then receive a valid acceptance from that applicant, and we look on the existing Appendix G data to confirm whether or not there's headroom. So is there sufficient headroom? Yes, there is. We will then add that generator onto the monthly update that we send to Grid on the affected GSP. National Grid will then sign that submission off, and then they'll then return that to us as soon as practically possible. So there isn't any agreed SLA for this particular part of the process, but as really Grid have already given us a headroom and that acceptance is within the headroom, it's more of just, you know, sort of signing off. There shouldn't be any delays with that process. Once we receive then the signed information from Grid, we will go back to that generator, tell them that there's headroom, and there'll be no kind of further applications that we need to make to Grid, nor will there be any kind of fees that are associated with National Grid submissions that are applicable to that. And we've made an SLA for that we will get back to the applicant within 1 month of having that information from National Grid. However, if there isn't sufficient headroom, we will then go back to the affected applicant and tell them that they can't proceed without a project progression. So a project progression is a submission that goes into National Grid. It's much more detailed than the information that's submitted for the monthly Appendix G update. And they will look in a detailed way at the affected applicant, any other applicants on that GSP who are also affected, and kind of come up with a plan moving forward. So we will tell the applicant what the fee is associated with that project progression submission, and it will be up to them whether or not that they want to proceed. So if the applicant doesn't proceed, the project progression won't be submitted. But because we can't progress without that project progression, excuse me, that will constitute a cancellation of your connection offer. So we would then at that point refund any unspent monies to you that have been paid in the acceptance fee, and that project would be considered as cancelled. However, if the applicant chooses to proceed, we will invoice the applicant for the fee to submit the project progression. Once that invoice is paid, we'll send those monies to National Grid, and then we'll also send the data regarding the scheme to National Grid as well. Grid will then confirm to us that the data submitted is acceptable and also that they've received payment. At this point, this triggers a 90-day clock by which National Grid have to come back to us with either a no works return or a construction agreement. So if for some reason there's a delay in making payment to National Grid, or if there's a delay in the data being acceptable to National Grid, that 90-day clock doesn't start. So it's only when Grid confirm that they've had the money and the data is up to standard that that 90-day clock starts. So if we receive a no works return, it means that Grid have identified that actually there is headroom without undertaking any further transmission reinforcement. Usually when that happens, they tell us that the affected customers in the project progression can connect, and they also usually give us a little bit of extra kind of headroom as well, which we can update then on the Appendix G information on the Heatmap tool. So sometimes you might see that a GSP has a B status for a few months, and then suddenly it reverts back to an A. That will be because National Grid have given us a no works return, which we've then accepted, and it's given us some additional headroom on the GSP that wasn't previously known about. However, if we get a construction agreement, it means that transmission works have been identified. So usually, typically more traditional kind of reinforcement on National Grid's network. So for example, kind of up in Harker, we're looking at replacing 4 SGTs and a full rebuild of the switchboards. They're actually changing that from a 275 to 132 to a 400 to 132 kV facility. So that's an example of like how potentially onerous the works can be on National Grid's network. So once we know what those works are, we will inform the applicant of the timescales that are associated with that work, rough timescales, and also then any associated security payments. So these security payments are calculated by National Grid. They'll be given to us with the information about the construction agreement, and we'll pass it on then to the applicant. The applicant, again, similar to the project progression, they can decide to go ahead or not. So if they don't want to proceed, that's absolutely fine. But as with previously, it would mean we have to cancel your connection offer because it cannot connect until those works are completed. So if none of the affected applicants as well on the project progression want to accept, we won't accept that construction agreement with National Grid, and if it's left for 3 months, it will just lapse. However, if the customer does wish to go ahead, so they accept the terms of the construction agreement, E&W will accept that construction agreement with National Grid within 3 months, because as I said previously, after that 3-month period, the proposed agreement lapses and becomes void if it's not accepted. So once that construction agreement is accepted, that's when it becomes a MODAP. So again, you may have heard of the MODAP that's in progress at the moment on Harker and also at Headroom. We will then continue to have discussions with National Grid to determine a programme. So the minimum I've been told where we can accept where there are required grid works is a minimum of 24 months from acceptance of the MODAP. However, it can be much more lengthy than that. So again, using Harker as an example, I believe we're now looking at December 2026 at the absolute earliest for those works to be concluded. So it can be like a huge variance in terms of timescale associated with the works. So to return back to the transmission capacity slide from the heat map, I've pulled out some examples here of an A, B and C. So Bredbury currently has an A status. So you can see there in column materiality headroom part 5, we've got just over 40 megawatts there of headroom. What this would mean is if we had an acceptance, say tomorrow, of 30 megawatts that was on Bredbury GSP, we would know that there is sufficient headroom on that GSP for that to be submitted to National Grid, and we wouldn't expect to have to do any further works. However, if we got an acceptance, say for a 100 megawatt battery, then obviously that exceeds the headroom that is indicated there. So what that would then do is trigger a project progression on that GSP, and you'd see in subsequent months the materiality status would change from A to B. Similarly on Penwitham, so that's the one kind of the lowest box down that I've highlighted, that currently has a B status. So you can see there that we've only got 7.9 megawatts of headroom indicated, but in the column that says capacity and project progression, there's over 60 megawatts. Again, obviously that greatly exceeds the headroom that we've had. So we've submitted this project progression to National Grid and we're waiting to see what they come back with. if we do get a no works return with additional headroom, we'll be able to update that to A and change the materiality headroom to reflect the new number that we've been given. However, if they come back and identify reinforcement works, then it will change as similar to Harker, which is the second box down, with a C status. And that's how that will remain until those works are completed. So I appreciate looking at kind of all the various numbers. It can be quite confusing looking at the heat map, particularly if it does indicate that there is headroom. But if you look at the capacity that's in the project progression or the capacity it's in part 4, you'll see that those schemes kind of greatly outstrip the materiality headroom. And that's why we're in a situation where they're either a B status or a C status. So I would suggest that when you are kind of using this like at a glance just to see if there's going to be potential problems, I would really recommend just looking at the materiality status. And if for any reason you're kind of not sure on the information that it's giving you, I'd recommend you just get in touch with us and we can discuss it with you in a bit more detail. So finally, as I sort of said before, if we've got an accepted connection connecting onto a GSP that has a current MODAP or a current project progression, then that can't proceed without agreeing to the appropriate works. So if you do kind of know or you get a heads up from someone that these issues are going on, it's not an option again for you to opt out. You'll either have to go into that process with National Grid or not proceed with the acceptance of that project. The materiality headroom as well on the heat map, it doesn't take into consideration headroom once the works are completed. So, for example, on Harker, if I flip back to this slide, you'll see that Harker's sat on a C status. So Harker will remain on that status until December 2026 at the earliest, when the identified grid works are completed. Once those works are completed, we'll get given a new block of headroom by National Grid, and all of those numbers will be able to be updated. But until that's happened, it will kind of remain frozen on that status until it's complete. And again, just to reiterate that we do update all the Appendix G documentation on a monthly basis. And as we update the heat map monthly as well, we make sure any kind of changes in that information from National Grid will get reflected on the heat map as well. So before I hand over to Gareth, were there any questions anybody wanted to ask about any of that?
Victoria, there's one on the chat. What's the difference between project progression and MODAP?
Okay. So the difference between the project progression and the MODAP. So the project progression is like the initial assessment by National Grid when we've identified there's insufficient headroom. So if we've got an acceptance and we know there's insufficient headroom, we submit a project progression to National Grid. And then the outcome of that project progression can be a construction agreement. And when that's accepted, that becomes a modification application. So a helpful kind of way to think about it is if there's identified works on a GSP, we're modifying that GSP. That's why it's called a modification application. And similarly for the project progression, we're submitting that to determine whether or not a project kind of can progress without any works or if it'll move into the modification application stage.
And as a follow-up, there's a question on what do columns A, B, C and D on App G mean?
Was that on this slide, sorry?
Not clear.
So I mean, if it was a reference to the columns on this, okay, part 1, yeah, no problem. So part 1 is schemes that are already kind of connected and energized on our network. Schemes in part 2 are schemes that are kind of waiting to connect, but they may have kind of a small requirement that's attached to them. So for example, having to operate in a certain power factor. Part 3 is where they're waiting to connect, but they'll have kind of significant curtailment that's associated with the connection before some works are completed. So, for example, in part 3, if you've got an accepted connection for 20 megawatts, you may only be able to export, say, 2 megawatts until some works are completed. And then the works in part 4 mean that you cannot connect kind of anything. They're waiting until those transmission works are finished. So again, Hark is a really fantastic example. That block of capacity that's sat in part 4, they cannot connect until the transmission works are completed. So again, that will remain there until those works are finished. I think just seeing a few more pop up on the chat as well. Okay, so do project progression and ModUp have separate fees? So you'll pay a fee to go into project progression, so it's usually around £20,000. And then once you get to kind of the ModUp stage, there are usually securities that are associated with that work. So I can't really advise on what the securities will be because they depend on a project by project basis. So they'll depend on the work that Grid are undertaking. They'll also depend on the size of the connection that you're looking to connect. And also as well, they can depend on sort of how far out you are from energisation. So Grid, they calculate those on a bespoke basis for each project. Okay, so Appendix G in terms of reducing timescales, the ModUp. So the project progression Grid need kind of those 90 days in order to undertake the assessment. I think the Appendix G process was designed to make it kind of clearer from the outset for which projects there would be capacity for and which projects there wouldn't be, rather than it being so much of an unknown. So where we have got the headroom available, it is very useful for customers to be able to sort of know when they accept that it's within the headroom and there aren't going to be any issues with Grid. Yes, absolutely, it's not a particularly speedy process if you do have to go down the project progression route and the ModUp route. But again, those kind of 90-day SLAs are defined both for Grid to get back to us and for us to respond back to Grid as well. And then I don't have any information, I'm afraid, Morgan, on Appendix E, but I can take that one away for you and kind of get back to you. So were there any other questions before I move on? Okay, if anyone thinks of any, as Lottie mentioned, there'll be breakout rooms at the end, so feel free to ask me then. But otherwise, I will hand over to Gareth, who's going to talk about the network headroom report.
Oh, hello, hi everyone. So my name is Gareth Freeman, and I am the Connections and Capital Manager for Strategic Planning. So the best way to think of myself and my department is we're the amps and volts for the section. So I'm just checking there. The slides have disappeared from myself. Cheryl, would you be able to put them up on the screen again? Or was I meant to present them?
No problem, I'll get them up.
So whilst Charlotte's just bringing these up, just to reiterate, we will have a question session at the end, obviously for any questions you think of throughout the presentations.
Thanks for that, Charlotte. So the headroom. So I'm going to talk to you about two things today. The first is the headroom report, which we published on our Defez webpage, and the second is the network development plan. So the two things are working in parallel and will be combined together in May 2022. But I'm hoping by the end of this presentation you've full clarity as to what that means. Next slide, please. For that, I'll just give a bit of background on this. So I'm on an ENA working group and representing EW on this, and this is something that we work on nationally with the other distribution network operators and National Grid. And we were given the instruction that people don't have visibility over the medium-term development of the network. We took this away as a working group and did a gap analysis, and we looked at two types of reports that we look at the moment. And it was LTDS, which is your 0 to 5 years, and your Defez, which goes from 0 to 2050. But in terms of anything past the 5 years, there was nothing there. So what we decided to do was put together something called the Network Capacity Report. It's called Capacity at the time. And what that was going to do was going to give you visibility of how the network's developing in the 5 to 10 year window. While we were actually conducting this and putting together a bit of a draft of what that would look like, BEIS issued a draft license condition for the GB implementation of the EU Clean Energy Package. And what that meant was there was actually a direct line about that, where DNOs would have to signpost headroom capacity in the medium term, which is the 5 to 10 year window, which seemed to fit in with work we were already actually working on in the ENA. So what we did with that was we took it away, and we said we'd work on that license condition and develop the formal statement for what was going to be called the Network Development Plan. So the Network Development Plan is slightly different to the Network Capacity Report because it has the Network Capacity Report within it, but has more detail, and I'll explain that in a minute. The new license condition for this came effective in December 2020. And what we said we'd do in the interim is we would, because we'd already done the work, we would publish our capacity report, which is now called the Headroom report, in August 2021. And that would allow us to take feedback from stakeholders and what they liked about it, what they didn't like, and then that would help form our implementation of the Network Development Plan, which has a publishing date in May 22. So the license condition is LC25B, and parts A to C define the necessary scope and content of the Network Development Plan, and parts E to H relate to the process for consultation, publication and submission of the NDP. The ENA working group focused on the formal statement, but some high-level points which define the scope of the NDP are: each DNO over 100,000 customers has to produce a Network Development Plan from May 2022 and every 2 years thereafter. They need to cover the 5 to 10 year ahead period, which follows on from the LTDS that covers 0 to 5 years. They need to report the network development requirements for new generation and load, and highlight areas suitable for new connections and flexibility services, using a best view of development covering all voltages down to 11 kV inclusive. And it needs to include a methodology document informing the user of underlying data and assumptions. So just there. So effectively, the Network Development Plan formal statement comprises of 3 parts. So the first bit is network headroom reporting. So it signposts parts of the network that are most suited to new connections, parts of the network where reinforcement is required, and parts of the network where flexibility is required. The NDP will also have 2 extra things on it, which is network development reporting, and that will give you an indication from years 1 to 10 of new infrastructure being put in place and flexible services that have been procured. And the third bit is methodology, and the whole point of that is, from reading the methodology document, you should be able to use the data within our document for whatever your needs are. So from that, I'll just give a live demonstration of the network headroom report, and then we can take some questions after. So I'll just share my screen. And what you can find is, just wait, can everyone see my screen?
Yep.
Yeah. So this is on our Defez page, which all you have to do is Google Defez ENWL, and it should be your first thing that pops up. And this has our distribution future energy scenarios, and it also has our network headroom report. We also have an accompanying PDF, about 15 pages, to go alongside it to explain what we're trying to achieve with it, and the workbook is here. So if you just click on that and download it, you'll be presented with this. So it's effectively a workbook. There are 2 interactive data tools. So these are the things that filter on the information and present it. And then the 4 underneath are your raw data, and pretty much everything in its raw form. So the basic way to use this is it'll give primary demand headroom and BSP demand headroom from 2021 up to 2030 in year increments. And after that, it's every 5 years up to 2050. So I just pick a random primary substation, and you'll be able to see that the headroom at the primary progressing up is such, and up to 2050, and that should allow people, major customers and people putting in large infrastructure schemes, to understand what's potentially in the future, and if there's any development. You can do the same for BSP Headroom. Again, you can filter on whichever BSP that's on our network, and generation Headroom, which works quite well. You select the primary, say Piccadilly, and this allows you to pick which type of generation as well, whether it's synchronous LV, synchronous HV, inverter based or battery storage, and that will give you a good indication of what's available and what you can apply for. With this Headroom report, we'll only put in things that are approved name schemes that we're going to deliver. So if I was to look at Goulburn BSP, you can see that we're actually replacing the switchgear in 22, and you can see there's a marked change in Headroom. Unfortunately, it's still in the red, but that's just due to the amount of applications that are in that area. But you can pick different generation, and it'll give you an indication of what you can and can't connect. If you want the other pages, it's just the raw data. Effectively, these things filter the data on this, and you can pick whichever scenario that you'd like to go for. We have 5 at the moment. 4 of them are based on Defez, and we have another one which is our best view. And that goes for primary head. This is demand, the first 2, and then generation afterwards. Generation is non-firm, so once something goes off, the generation goes off as well. But for demand, you can get firm and non-firm. So with that, I'll just take this opportunity to take any questions on the Headroom report. As I said, there's another breakout session as well. So if you don't think of any questions now and something comes to you later on, I'm more than happy to answer it then.
We do have one on the chat.
Okay, that's fine. I'll just have a look.
What does non-firm mean?
Non-firm, it's when you apply, you can be given 2 options, firm and non-firm. Firm, it means that if there was an outage on the network that you're connected to, we would have the facility to be able to backfeed and keep your load or generation, so keep your load on, or else to allow your generator to generate onto the network but in a different part of the network. Whereas non-firm would be, you would take a single point of connection, it would be radial would be the name, it would tee off along our circuit, and if there was any issues and there was a fault on the network, it would be taken offline until we'd completed our restoration. Does that help yourself, Morgan? No, it has nothing to do with how many transformers are in service. So it's just to do with what the network can take at that particular time, and how you're connected onto the network. No problem. So with that, I'll just stop sharing. I've stopped sharing my screen now, so I'll just go back onto the presentation, slide demonstration. So I'll talk about the development plan and the 3 stages of it, which will be May 2022. So I've just shown you the Headroom report, which is something that we published in parallel to the makeup of the network development plan, and it was just a chance for us to get feedback. So when we actually publish our network development plan, it's in the best possible shape, and it's received stakeholder feedback. So for the network Headroom report, when we looked at the actual requirements of the license condition and what's expected of us, it's broken down into a number of things. So I have a table here, and anything in green is where we've exceeded the requirement, where we thought there was benefit to go above and beyond. So the date range is every year to be covered individually between 1 to 10 years, and then after the 10th year, this requirement moves to every 5 years up to 2050 and aligns with the Defez timescales. And the whole purpose of that was we wanted to make sure that there was continuity, that you could look at the network Headroom report and not need to go to the Defez. It just gave you that, just combined it, and we felt that it just brought a level of continuity to all the reports that are being published. So the network capabilities and assessment methodology. So demand and generation capabilities are given in terms of spare margin in megawatts per year and per scenario. And this will reflect approved network developments and delivery, including asset-based enhancements. So that's when we went to Goulburn. If you remember when I was showing the sheet, it showed after the switchgear change there was an improvement in capacity available for headroom. And the information to be considered of thermal loading and fault level constraints as a minimum. Coverage. So the coverage is for all BSP and primary substations down to including the primary secondary voltage. So it goes from the BSP level, so bulk supply point, down to the HV bars at a primary substation. The format and publication. So we put it in tabular nature, and we deliberately picked Excel because we felt that was probably the best. That's something that people are most familiar with and will have access to be able to utilize. And for the Headroom report, this is a green stretch target as well. If you remember, the requirement for the network development plan is to be published every 2 years. So what we're going to do is the actual Headroom report side of it, which is the capacity, we're going to publish that annually, and that makes sure that it aligns with the LTDS information and the Defez, which are both yearly. We thought that was most appropriate. And the information sources, so we take our information from the LTDS and the Defez. So the next bit of this is the network development reporting. So in the first slide, we're talking about capacity and the headroom available. The next bit is development reporting. And I think this will actually have quite a bit of value for people who are looking long term and how things are developing, and to be able to keep an eye on scenarios or situation or developments on our network. So it's a list of high-level plans for network interventions and flexible services for the years 1 to 10. It gives the location of the intervention, covering the whole network down to the primary substation HV bars. It gives the development requirements for flexibility services and new infrastructure. It gives a justification for the need. And what I think is very value added is it gives where it resides in the delivery lifecycle. So you'll be able to see whether it's just being signposted at the moment to us, whether it's an approved plan, whether it's in delivery. So you can see and get a good feel of where it's up to in the process. Flexibility services, we'll focus on providing magnitude, year of intervention, and likely duration for how long we'll need that flexible service, and the nature of the requirement or flexibility product. The new infrastructure will be timing and high-level scope of intervention and the construction duration. It'll give the details and connectivity, and it'll give the asset quantities, circuit lengths, number of transformers, what's been changed, and it'll provide equipment ratings. Lastly, so you had the headroom side, you had the development reporting, and that's the methodology. So this is so we can provide sufficient detail to provide stakeholders with enough detail to understand sensitivities and extrapolate the NDP results. So effectively, from reading this, you should be able to understand exactly where we got our data from, how we've used it, and you should be able to apply it to your own situations. I've just seen I've got 2 questions in there, so I'll just check. When will ENWL publish the latest version of the LTDS? We've published this year's already, I believe, and the next one is in development. I don't have a timeline for that, but what I can do, Mohammed, is come back to you on that one. Okay. So, part of this journey this is a brand new report, and it's to give people an understanding of where we are in medium term for network development. And because it's a new report, we want to make sure that everything we're doing just isn't done in a silo, and we're making sure that we're engaging with stakeholders as much as possible. We're very keen to hear your thoughts on things as we publish them to make them better for the whole use. One of the recommendations that came out of the report we issued on how the network development plan should evolve is we've asked for the governance structure to be held within the ENA and maintained within the ENA, and not actually have a formal review or attached any code updates. And this allows us to be quite agile in how we update the network development plan and apply any modifications. And it just means that we can spend the few years incubating the development report, getting it really high value adding to customers through that governance structure. We've also recommended that we review the LTDS itself and the capacity elements of that, and whether that sits better in the network development plan. But that is currently ongoing in the LTDS review, which is another ENA project, but nothing has been confirmed on that yet. And we've also asked for a review on existing capacity, or we've asked for a review on the communication between, or the information shared between National Grid and ourselves, to make it more open, to help customers understand what the capacity requirements are at the transmission boundaries. So the next steps for ourselves, and this is an ENA slide, is we've published our network headroom report. We published a draft paper on the formal statement for the network development plan. So we're in the feedback stage at the moment. So I'd encourage, if you have any feedback after using it, if for the next week or two, if you could feedback that to myself, and I'll leave my contact details at the end of this presentation. Because we're finalising a report on the formal statement for the network development plan, and it's to be published in December this year. And that gets us all in line to produce the network development plan itself in May 2022. So I'll leave a questions, but please see that my contact details are below here. If you have any further questions, I'll be happy to answer them. So with that, I'll pass you over to Keith, and thank you very much for your time.
Hello, my name is Keith Evans. I'm the DSO Transition and Smart Grid Engineering. I'm the Flexible Solutions Manager at Electricity Northwest. So I'm going to be taking you through our DSO update to start with. So far this year, we have updated our DSO. We've published a DSO transition plan for ED2, which is our draft ED2 transition plan. That's available on the website and gives you an idea of what we're planning to do within the 5-year period between 2023 and 2028. It is draft. The final version will be published in December of this year, and that will be going to Ofgem to review to determine what funding we have available to us for that period. But it does give quite a good context of what we're thinking of doing within the ED2 period. Alongside that, we've also got our DSO strategy, which was published in 2020. And again, that just gives some context of our plans for ED2, but more kind of general what we're planning to do on the full kind of DSO journey and net zero. So the next thing, I'm going to take you through an introduction to active network management. Now, active network management, it's not very well communicated so far. So I wanted to kind of take you through some of the points of active network management, just so that kind of you all understand where we're coming from with it. So the active network management system, it's just a piece of software that we're putting in place, which will allow us to connect with elements of the smart grid, such as generators, storage, controllable demand, and other DER. And it helps with our control systems in terms of speeding the speed up of decision making, and allows us to automate a lot more of that decision making, which hopefully should make it easier to connect more people to the network and facilitate the green transition. The reason why we're talking about it today, because we're actually not planning to go live with it until the beginning of 2023, is because we're in the final stages of implementing our new network management system, which will be used to facilitate the A&M system to be integrated. And that's been quite a long process so far. Which is why we're potentially a little bit behind some of the other DNOs with putting the A&M system into operation. But we would like to think that actually we've learned a lot of lessons from the other DNOs as we've been going through to actually produce quite a good system. In order for the system to work correctly from day one, we actually need to integrate quite a lot of the flexible connections into business as usual. And to get them ready so that when we actually put the A&M system into operation, that they're ready to go, and that actually people are getting the maximum benefits of that system straight away, rather than waiting 1 to 2 years it takes normally for a new connection to come into force. So the A&M system, it offers a number of benefits. It's going to allow for faster connections, which will, because we're hoping it will trigger the requirement for less reinforcement overall, which also then brings cheaper connection costs because we can use the existing capacity within the network rather than having to build new assets. And that could be a kind of staging post for like future requirements if people ask for firmer connections, or it could be a permanent solution. It allows the amount of time that generators can remain on supply. So at the moment, you'll all be quite aware that the current stance is if there's a fault on the network or we need to do some maintenance, then quite often the default position would be all generators go off during the course of that work. It's very binary, whereas the future will be that it will be more kind of it will be based on a percentage of your capacity, and so we can actually feather how much capacity we're asking people to constrain by if we do have an issue on the network. We can get more network utilization, so we will be able to run the network harder, which then means that obviously it has kind of better better requirements before we need to reinforce them. There's the decreasing of reinforcement, which offers financial savings for everyone connected to the network, and also less embodied carbon. It will allow us to utilize more flexible services. So again, they help defer reinforcement, and I'll talk about them a little bit later. It facilitates the market to establish use to trade energy. So it's not just good for us, but actually it will allow people within our network to trade between themselves, and it will help facilitate some of that. And then the final thing is it will increase the security of supplies by allowing us to increase the amount of automation that we've got on the network, decreasing the overloads and increasing the speed that we should be able to restore people following a fault. So I'm going to go through a typical example of the A&M system, just to kind of give you some context of what it is. So a typical primary single transformer, it has a kind of cycle, it has a variable load during the day, and we've got this, it has a maximum 100% capability in terms of its firm rating, but we can run them slightly harder every so often, up to generally about 130%, but that's for a very short period of time before we start damaging the asset. And then for really emergency situations, we have extremely short ratings for some of this equipment. So a lot of our substations at primary sites have 2 transformers. So it's a really good example of where the A&M system can offer us benefits. So at the moment, we would design the system so that the 2 assets together would run at 100% capability across the site. But actually that means that we're sharing the demand equally, or the generation equally, across the 2 transformers. So actually we're only running them at 50% each per transformer. And that's because if we were to have a fault on either of those 2 transformers, then the other one would have to pick up the remaining load. So we obviously can't run them to 200% of capability because they won't operate like that. So with an A&M system, what we can actually do, what we can actually do is we can load those transformers up by an additional 15% each. So taking the substation up to 130% of its firm rating. And that's fine. We can run the network quite happily at that all day long because neither transformer is overloaded. However, in a fault situation, we've lost one transformer, the second one picks up the remaining load and is loaded up to 130% capacity, so that's within its cyclic rating, but it's only able to do that for a short period of time. So we then need to reduce the demand or generation on that transformer. So what the A&M system does is it will detect that the transformer is overloaded, and it will dispatch either flexible services or it will trigger constraints to reduce the demand or generation by the 30% that we've overloaded it by. And that then brings it back into normal running conditions. And we've actually only we've allowed more generation to be connected to the network for most of the time. And for this small period of time, we've just constrained 30% of the capacity or brought on enough flexible services to cover that. So if we could get that kind of capacity out of a standard double primary substation, we can also use the same logic for the rest of the network. And we've got many thousands of kilometers of cables and overhead lines. And then we've also got thousands of substations. So if we can apply this everywhere across the network, then actually this is a massive amount of additional capacity we can add to the network. So if you're interested to know more about active network management, please get in contact with us. I'm keen to kind of do some of the myth busting because at the moment, some of the A&M systems are getting a little bit of a bad press. And actually, for the types of people who are on this call today, actually they offer great benefits to allowing you to connect faster and cheaper onto the network. The next bit I'm going to talk about is flexible services. So this leads on quite nicely. So in order for us to reach our net zero future, the way that we run the network is changing. We're moving towards distribution system operation, and that means that we will have more local network management, and we're bringing on these flexible services which will help to manage the network. So a flexible service is where we will pay generators or demands to help change the amount of energy running through the network. So at the moment, all of our flexible services requirements have been to reduce the demand on the network. So that would be a generator could increase their demand, their output, or we could have demands reduce their demand. And this also could include permanent energy efficiency measures that can be put in place. So the theory on this would be that the generators and the DERs will, when instructed, change their demand or generation profile, and then we will pay them for that change. To participate in one of our tenders, you must have an asset in one of our requirement areas. You must be capable of adjusting how much electricity you can consume or generate, and you must be able to provide at least a minimum of 50 kilowatts of demand change, either individually or via an aggregator. And if you want to find some of our, if you want to find out where we're currently offering these, then we have a flexibility map on our website, which shows all the various regions that we're currently tendering for requirements. And then it also shows the future requirements. So the dark blue are our current requirements, and then the lighter colour would be our future requirements. And the different codes on it show the 4 different energy products that we procure. And again, if you want to get more information on what those products are, then there's quite a lot of information available on the website. We actually have a tender which we launched last Friday. So we're currently looking for 259 megawatts of flexibility across 37 locations within the Northwest, and this is worth up to £2 million. If you're interested in this, then again, go on our flexibility map, go on our current requirements page. And there's a timeline of the requirements at the moment. So we're looking for people to register their assets by January, and then they can go into the bidding sections between January and February, with a final contract award within March. And the requirements that we're looking for at the moment are for going from the winter of 2022 all the way through to 2024. We're holding a webinar at the end of December, at the beginning of December, on the 3rd of December. And the topics that will be covered will be DSO transition, flexible services, and our path to net zero. So if you'd like to sign up to the event, please do. And if you want to talk to us about flexible services, please feel free to get in touch with us. The final topic I'm going to talk about is our accelerated loss of mains change programme. The accelerated loss of mains change programme was set up following a change in the distribution code, which requires that all generators must now have appropriate rock-off loss of mains protection, or have the loss of mains protection disabled if they're applicable. This is specifically looking at generators that were connected before February 2018, which would have had either the old rock-off settings or they would have had vector shift. Now, vector shift has been completely banned, and the rock-off settings have been adjusted to allow for more headroom on the network. So generators must be compliant by the time we get to September 2022, and that's the requirement. Now, we actually have funding available. There's a year left on the programme, or just less than a year left on the programme. So you can get the changes funded if you're doing this. I will say that the funding is going to start decreasing as of the next window. So if anyone has any assets, then I would encourage that you start getting them loaded into the system as soon as possible, because the funding will taper off over the rest of the year. Please do, if you have any of these assets, or if you know anyone who has, get in touch, figure out if you've got the right protection, and get it updated as soon as possible, please. Thank you very much. Any questions for me?
So Keith, there was one in the chat referring to A&M, asking why can't A&M allow both transformers to be fully utilised, and then if one transformer is unavailable, turn generation down? Is it because it's not quick enough?
It is. Anything over about 130% of a transformer's rating, you will be doing irreparable immediate damage if you take it beyond that point. So really the only way we could do it, it could be done sub-second, but the communications links that we have wouldn't facilitate that, which is why if we ever do that situation, then we end up with hardwired control to sites, and that's been quite a historical thing, that they have had hard control to some sites previously, but we try and avoid doing that because it's not particularly nice to do. So the honest answer is it would break the equipment if we tried to take it beyond that point.
Okay, thank you, Keith. Are there any questions for anybody else? In that case, I will move on to the discussion rooms. So a few have already added in, and it seems that network information is the popular group. If you would like to add which room you'd like to join into the chat, we can move you around. I'll be kind of hosting the main room. So if you do want to leave the room that you've joined, there is the option to click leave, return, and that'll bring you back to the main room, and I'll assign you to the next room. The breakout rooms aren't recorded either.
And just to reiterate, clicking leave would leave the full webinar. So if you want to return to the main room and be reassigned to one of the other rooms, please click return, and Charlotte will put you into whichever room you would like to visit next.
Okay. So I'll open up the rooms now.
These are open forum rooms for discussion. Any questions, any comments, it's up to you.
We do have Hannah and Brian in the main room, so if there are any questions that want to be asked in this room, please feel free. I'll also turn the recording off now.